This is one of a series of videos produced by the Further Maths Support Program for online revision. In this particular video we're looking at the AQA D2 specification and question 3 from the January 2011 paper. The question is one about game theory, and we can see that we have two people, Rona and Colleen, who are playing a zero-sum game. And the game is represented by this payoff matrix for Rona. And we're told in the question there's a value x and that is less than 2. So to start off with, we're asked to write down the row minima and show there is no stable solution. Then to explain why Rona doesn't play strategy R3, and finally to find the mixed strategy for Rona and the value of the game. Well, the three row minimum values given for Rona are just the smallest value in each row, literally that, so 2 here, -3, and a value x. And then we're asked to show that there is no stable solution. So what we need to do is to find the what's called the Maxi Min Value. So we want the largest of these minimum values, and that's equal to 2 because x is less than 2. So this is what's called the Maxi Min Value, and we need to compare that with the mini-max value for the column. So we need to work out the column maxima values, and those turn out to be 3, 6 and 4. So there's no stable solution. So the mini-max values, or the column mini-max, is equal to 3. So we need to simply say that there's no stable solution as the row maxi min value is not equal to the column mini-max. And that implies there is no stable solution. There were 4 marks in total for part A of the question, so just looking at the marking there. There was a simple B1 mark for writing down these row minima, and then 3 marks allocated B1 for working out the column maximum values, and then a method and answer mark for stating that the row maximin is not equal to the column minimax. Now I'm going to explain why Rona should never play strategy 3. Well, if we look at strategy 3, we can see that the values there of something which is less than 2 here, so and therefore this one here must be less than 5, and we can see that those values 2 or less than 2, less than 5 and 3 are all going to be smaller than the values that she has in R1. So we can say that R1 is always going to be a better strategy than R3. So we say that R1 is always better than R3. Or you could say that row 1, R1 dominates R3 is the other way of saying that. And there was a single mark for that explanation. The next part of the question then asks us to find the optimal mixed strategy for Rona. And we do this by first of all assuming that Rona plays each of her strategies R1 that are available now with probability P and 1 minus P. And then we look at what happens when Colleen plays each of the different strategies. So if we need to write down what we're doing now, if C plays C1, we can look at R's expected gain, and so that's just a case of taking these two values here, 2 and 3, and multiplying by the probabilities. So that R's expected gain is 2p plus 3 times 1 minus p, and that is equal to 3 minus p, so just by simplifying it. Similarly for C2, we get 6p minus 3 times 1 minus p, which in total is 9p minus 3, and for C3, 4p minus 1 times 1 minus p, so that's 5p minus 1. If we now indicate these values onto lines on a graph, where on here we have the probability going from 0 up to 1, and the expected gain then, if Colleen plays C1, is 3 minus P. So when P is equal to 0, that gives us a value of 3, and when P is equal to 1, a value of 2. So we have a line going from 3 down to 2. Now, I would always advise that when you do that, you indicate on your diagram where that particular line has come from. So that's come from C1. In the next one, we have a value of 9p minus 3. So when p is equal to 0, that gives us negative 3, and it's got to go up to a value of 6. So again, we need to put a line in to show that. And finally, for C3, we're going from negative 1 when p is equal to 0 up to 4 when p is equal to 1. Now you can see that we need to do this quite accurately, because what we want to do now is to find the point, the highest point, which is below all of these lines. So if we just sort of move up these lines, you can see that we are staying below them, and therefore the highest point we reach is at this intersection here, the second intersection that we meet. And that one there is the intersection of line C1 with the third line we did, C3. And therefore we want to solve the equation which comes from C1 and C3, which is 3 minus p equal to 5p minus 1. So that gives us 4 is equal to 6p, or p is equal to 2/3. So the mixed strategy for Rona is that she should play R1 with probability 2/3, and therefore R2 with probability 1/3. The value of the game that comes from that we can simply get by substituting the probability that we found into one of these equations. So the value of the game using 3 minus p, which is the first equation, is 3 minus 2/3, which is equal to 7/3, or 2 1/3 if you prefer. Okay, the marking then for this part of the question went as follows. There was a method mark and an accuracy mark for doing each of these equations, and then another method and a mark for transferring them onto a graph, a method and a mark for solving the correct pair of equations, and showing that Rona, or explaining that Rona's play safe strategy was as we've indicated there. Finally, a single mark B1 for getting the value of the game as 7/3. Right, that completes this particular question. There are other questions you can find at www.furthermaths.org.uk.